Hi students, let us see today how to compute the DFTs for a sequence using direct DFT computation method and also plot the discrete line frequency spectrum. Okay, so let me choose the PDF first. Okay, so now you can see here the question has been put up here. Compute the DFTs of the following sequences using direct DFT computation. So also plot the discrete line spectrum. So now for this, for the particular sequence in time domain given x of n is equal to 2 comma 3. So here you can see there are two values in this sequence, in this discrete line sequence. The length of the sequence is happens to be 2. So we write the length with the capital N notation, that is equal to 2. Now here he hasn't specified what point DFT computation has to be done. So generally it is stated as n point DFT, capital N. We take capital N point DFT. So here n being the length of the sequence. Here sequence length is 2. So let us compute its 2 point DFT. Generally he specifies what point DFT you need to calculate. So now here n being 2, we will find 2 point DFT. So considering the expression for n point DFT as we know in the class I told you, DFT of x of n is given as x of k. The notation for DFT sequence is x of k, and the definition for this is given by the product of x of n with the total factor w suffix n raised to k into small n, or a range which is shown with the summation of small n being 0 to the length of the sequence, that is 0 to n minus 1. So the range of this summation will be the length of the sequence. We calculate the DFTs for DFT sequence for different values, for k being varying again 0 to n minus 1. So the length of the DFT sequence is also equal to capital N. So here capital N being 2 and x of n, your discrete line, discrete sequence is time domain sequence is 2 comma 3. We will calculate the x of k for that. Now if we see x of k can be written for that length of 2, small n being 0 to n minus 1. 2 minus 1 happens to be 1. This summation length happens to be 0 to 1. In summation of a product x of n, your time domain sequence, multiplied with the phase factor or the total factor w suffix n, capital N happens to be 2 raised to k into n. We calculate this product for different values of k ranging from 0 to n minus 1. N minus 1 happens to be 1 here. 2 minus 1 happens to be 1. So 0, 1. So again here DFT sequence is of a length 2 only. So now coming here, this expression has to be expanded for by substituting first for small n. So we will get for small n being 0, I will get the first term here. So for small n is equal to 1, the next term plus I will get the second term like this. So based on the length of the sequence, that many number of terms will come in the expression of x of k. So note that this should be written capital X. So always the DFT sequences have to be written with capital X notation. Here it has been not written. So here discrete or time domain sequence have to be shown with small x. Okay, this correction need to be done, capital X of k. Now substitute the values of x of 0 and x of 1 from the given input sequence. So x of 0 happens to be 2, x of 1 happens to be minus 3. Now coming to this, x of k, x of k equal to Small n being 0, I will get x of 0 as 2 into w suffix 2 raised to 0 plus x of 1 into w suffix 2 raised to n being 1 here. So here in the first term n being 0, here in the second term n is 1. So after substituting the values of these discrete sequence values, I will get in the first case 2, 2 into 1 becomes 2, minus 3, x of 1 is minus 3, so minus 3 into w suffix 2 raised to small n is 1, so only k comes up here. So this is the expression for x of k for after substituting small x of n values. So we need to calculate this x of k for the length x k equal to 0 to n minus 1. So the two DFTs are to be computed by substituting k equal to 0 and k is equal to 1 accordingly. So in the expression of x of k. So we will get, when you substitute for k is equal to 0, in this expression, I will get x of 0 is equal to 2 minus 3 into w suffix 2 raised to 0, right? Accordingly, k is 0 here. So I will get 2 minus 3 into 1, that is 3. So the net value is minus 1. So the first DFT sequence x of 0 happens to be minus 1. So coming to the next value of DFT sequence happens to be k is equal to 1. So k, substitute k is equal to 1 here in the expression of x of k. So I will have to write 2 minus 3 into w suffix 2 raised to k is 1 here. So the value of w suffix 2 raised to 1 happens to be it can be calculated rather with the exponential notation e raised to minus j 2 pi by capital N. W suffix 2 raised to 1 happens to be, we know that w suffix 2 is e raised to minus j 2 pi by capital N into 1 it is. So accordingly we substitute for this w suffix 2 only here, e raised to minus j 2 pi by 2 pi, then whole divided by n. N is what? 2, capital N is 2, right? The power is 1, so 1 is also multiplied accordingly. So the net power of this exponential happens to be e raised to minus j pi only. So 2 cancels. So accordingly I will get 2 minus 3 into e raised to minus j pi. So substitute for the calculate the value of e raised to minus j pi. Accordingly we will write this e raised to minus j pi in this form, cos pi minus j sin pi. Use that and find the value of this term. So I will get 2 minus 3 into bracket, cos pi is minus 1, sin pi is 0. So minus 1 minus 0 happens to be minus 1. So minus 1 multiplied with minus 3 happens to be plus 3. So total it will be 2 plus 3 equal to 5. So I will get the DFT sequence as x of k is equal to x of 0 comma x of 1 accordingly. So x of 0 happened to be minus 1, x of 1 happened to be plus 5. So this happens to be our DFT sequence for the x of n being 2 and minus 3. For that I will get DFT values as minus 1 comma 5 accordingly. Now in the question he has asked, after finding this DFT, this method of finding the sequence is direct DFT computation method, and he has asked along with this plot the discrete line spectrum. So discrete line spectrum is shown with accordingly with the graph. Along x-axis we write down the number small n, and its value is being shown with the vertical lines, so based on the magnitude of that value. So here in the left side the discrete line spectrum, generally the discrete line spectrum consists of only magnitude spectrum but no phase spectrum. Phase spectrum also can be shown up by finding out the values of the phase of each DFT sequence values. So, but here, that in the discrete line spectrum, for x of n, 2 and minus 3 shown accordingly here in the LHS, and its endpoint DFT happens to be minus minus 1 and plus 5. So accordingly we will show this. Minus 1 happens to be at n equal to 0, and plus 5 happens to be at n is equal to 1. So accordingly we will show at here, since we are plotting here in the endpoint DFT of this along x axis, we show k instead of n here, small n here, capital K here, and its magnitude happens to be the x of k value, that is the DFT value of that particular sequence number. So at k is equal to 0, I get minus 1. Accordingly, I will show with a negative magnitude of 1, and with a positive magnitude of 5, I will show at k is equal to 1 here. So and again this is also shown in a discrete way. So, but here this is in the frequency domain, this is in the time domain. So I hope you understood how to calculate the DFT of a time domain sequence.